This video is an explanation of the charges and ionic bonding. First thing we're going to talk about is how to find the charge of an ion. Second thing we're going to talk about is how to make a compound using the charges. And the last thing we're going to talk about are the polyatomic ions. First, if you're trying to find the charge of an ion, you have to look at where it is on the periodic table. It's a family characteristic. The families share charges. So the first three columns, ignoring the transition metals, are all cations. They're positive. They are going to lose electrons to become stable. The alkali metals are going to be 1+, so hydrogen family. Hydrogen is not a metal, but it's in that column. Hydrogen, lithium, sodium, potassium, rubidium, they will all be 1+. The whole alkaline earth metal family, Be, Mg, Ca, they're 2+. You go over to the boron family, B, Al, Ga, they are going to be 3+. There is no charge associated with the carbon family because they're going to either gain 4 or lose 4. There's no advantage to it, so they don't make a strong ion. Now, the anions are going to be the nitrogen family, the oxygen family, and the halogens. The nitrogen family is going to gain 3 electrons to become stable, making it a 3-. The oxygen family is going to gain 2 electrons to become stable, being 2-. And fluorine, that whole family, fluorine, chlorine, bromine, the halogens, they're going to gain 1 electron and become stable with a -1 charge. Noble gases don't make charges. So how do we find the charges of these different elements? You're going to look at the periodic table, you're going to identify them, figure out what family they're in. Sulfur, for instance. Sulfur is in the oxygen family. That entire family has a 2- charge, so sulfur is going to be S2-. Barium is going to be a metal, so we're going to look over on the left side of the table. There it is, Ba. It's in the alkaline earth metals. It's a 2+ charge, so Ba 2+. Now, a very important skill for this unit and also the upcoming units for like chemical reactions will be forming compounds from the ions, knowing their charges. So let's take boron and fluorine and see what we can do. First, we're going to need to find them on the periodic table. So boron is B, fluorine is F, boron is 3+, fluorine is 1- because of their families. So we have B 3+ and F-. Taking a look at this, we don't have enough negative. We have 3+, we have 1-, we need more negatives. So we'll add a fluorine. Now we have 2 negative and 3+, not quite there. Add another fluorine, now we have 3-, 3+, we're good, we're balanced. The total charge would be 0. So we have Bf3, which means 1 boron, 3 fluorines. Let's try sodium and oxygen. So first you find sodium and oxygen on the periodic table. Sodium is Na, oxygen is O. Sodium is an alkali metal, it's 1+. Oxygen is in the oxygen family, it's 2-. So right now we don't have enough positives. We have 2-, we have 1+. We need more positive. So if we add an extra sodium, now we have 2+ and 2-. That's good. 2 sodiums, 1 oxygen, Na2O. The transition metals are different because their charge is not set. They have multiple different positive charges they can have. But it's pretty easy. Iron 2 is going to be iron 2+. Iron 3 will be Fe3+. Copper 1 would be Cu1+. Copper 2 would be Cu2+, and so on. How does this work if you're making a compound? Just like the other ones, except now you don't need to look at the periodic table to find the charge of the metal. Lead-4 would be Pp4+. Nitrogen, well, you would have to look at the table for that one. That would be N3-. Well, since we didn't have enough negatives, we had another one. Now we have 4+ and 6-. Not good. Well, now we had another Pb. Now we have 8+ and 6-. So we have too much positive, not enough negative. Add nitrogen. 8+. 9-. Okay, we need more positive. How about that? 12+ and 9-. Nope. There we go. 12+, 12-. Pb3, N4. How about the polyatomic ions? The polyatomic ions are listed for you on the polyatomic ion list on the back side of your periodic table. You don't need to memorize these, you just need to match the name with the symbols and write it down. So nitrate. If you were given the word nitrate, you look on the pi atomic ion list, you would find the word nitrate, and you'd see that that is NO3-. Well, what do these different things mean? That negative means it has a -1 charge. The 3 at the bottom has nothing to do with the charge. The 3 on the bottom is how many oxygens there are. 1 nitrogen, 3 oxygens. Overall, -1 charge. So how do we put these things into formulas? Let's try with magnesium and that nitrate we just looked at. So you look at the periodic table, magnesium is Mg2+, the nitrate was NO3-, so right now we have 2+, 1-. We need another nitrate. Now we have 2+ and 2-. That's good. We put them together, cation first, anion second, but we have to put parentheses around the NO3, otherwise we'd say NO32, and that's not right. We have 1 magnesium, we have 2 nitrates. So you put parentheses around NO3 and the 2 afterwards. Hopefully this helps clear up some of the confusions of these charges, and thank you for watching.